Hello, welcome to some more Java programming. This is Owen Riley again, and we're going to look at recursion. Recursion is a new way of well, it's not new, but for us, it's a new way of thinking about things and problem solving. We have so far taken an iterative process in our problem solving. In other words, we've gone sequentially through a section of code and we've only branched if we've had if statements or if we have return statements or break statements. That's how we change our direction. That's kind of iterative programming. Well, we're going to add to our iterative bag of tools here and have recursion. Recursion is where we have a complex problem as illustrated by this tree. A complex problem that gets reduced at the beginning or at the end, before you start the problem solving, to the very base case, our simplest case. This was actually drawn using recursion, and what it is all these branches are exact duplicates of the first branch. But the tree is not drawn from out at the end. No, it's drawn from the beginning and branched out, all making duplicates. So in other words, the problem is reduced from the complex on the outside to the simple on the inside. And that's what we're looking for as well. This simple case, also known as our base case. It's our most basic case. And when we get to our base case in recursion, then we know we can go on and start to solve our problem. So let's look at some Java code to see how we implement recursion. As I said, we've done things iteratively in a process. Recursion means a method can call itself with a different set of arguments. That's what really happens, is every time in recursion when you look for that base case, you keep calling your recursive method from within itself with a simpler set of parameters until you get to that base set of parameters, and then you work your way back out, just as we saw in that tree. You start at the base and then work your way back out. So for these examples, we're going to show you both an iterative way of doing things and a recursive way of doing things. Anything you do recursively, you can do iteratively. One of the benefits for recursion is it oftentimes leads to simpler looking code. It's easier for some people to understand, and usually it involves, like I say, fewer lines of code. A knock against recursion is that every time you recursively call a function, then your current in your method execution stack, the current method that's being executed is temporarily suspended while the new method gets called and processed, and we keep adding things to the stack, which sometimes takes up a lot of resources. So those are the points for and against. One, it's simpler to code. It's a new way of thinking of things. And that's one good, and one bad is sometimes the stack gets overloaded, and you could have a stack overflow if you have an endless recursive call. So let's see what we're going to do here. In this first example, all we're going to do is going to take an array of numbers, the numbers 1, 2, 3, and 4. And remember, these commas are not really in the array. They're just here as part of the syntactical needs of Java to separate these things as our tokens, as we've seen token processing just recently. But in the printout, these aren't really here unless I add them. Keep that in mind. So let's first look at how we print this iteratively by calling our itPrint method with our array called A. And our it function looks like this. It's down at the bottom. It's a nice simple one. It just uses a for loop, and the way we'll add the commas in a for loop is we will have an index that starts at 0, goes until the array's length is met, and we'll add to it each time. And we'll simply ask if this is the last number in the list. If the index is equal to the array length minus 1, in other words, if the index is 4, the array length minus 1 is 4, then that means it's the last number in our list. And the list we're in our array, the last one in our array. So in that case, we just want to print the array value and no comma. But if it's anything but the last one, what we want to do is print the number, the value itself, followed by a comma, and that's how we get it looking like this. There's really no other way I can show, but just trust me, this is the iterative one, and this is the recursive one. Now, in the recursive method, we need to. So really, before I go to the recursive method, in the iterative method, we also look for this base case here in this example. In other words, we're looking for that simplest case and taking some action differently than when we have all the other cases. And in the recursive method, which is this one right here, we're again looking for that base case. When we reach the simplest case, then we'll print out. Otherwise, we will just recall our we will print out and then recall our function, re-invoke it. So here we go. We start off in the iterative one as saying system.out.print array.index. Well, remember what we sent it the first time through wasn't, well, we will send it as soon as I uncomment out that line, will be our array and an index of 0. So right now we have our array A and an index of 0. It asks this: if the index is less than the array length minus 1, that means we're not at the end. Then after you print that value, then print a comma. And then recall this method. Here's the recursive call. Recall the method, but this time up that index. Send it a new index so that we can get to this base case, and when this sends us down here, then we just print out our last number. So in this case, we're going to do all of this every time until we get to our last one, when this is no longer a true statement, and we'll come down and do this print. So in this case, you can see we use about the same amount of code, whether or not it's recursive or iterative. Pretty much the same idea on this simple example. Let me run it for us one more time. I don't know if I ran it actually yet. I just have the results there. And that's what it looks like. Our recursive call and our iterative call looking exactly the same, which is what we're going to expect to see out of each one of our examples today, because we are comparing the iterative versus the recursive methods. So these are short programs, so you can just take screenshots of these yourselves and get them good to go. There's the main method and our recursive print method. Pause there for a second or two. And then this is our recursive method followed by our iterative method. So again, I always urge you enter these, get them working. That's when you really know, that's when you really start fighting with things sometimes, when you got to try to get them to work. Read those error messages, fix those compile errors for sure. Okay, our next one. This is going to be called EX002 reverse text reverses versus iterate round 2, I guess. So let's look at our main method to start, see what we're going to do here. In this one, we're going to ask our users to enter a string. And we're going to read in a string, and our test string will be A, B, C, D, E. But you can enter any string. You could enter a sentence. You can enter anything you want here, as long as it's going to interpret it as a string. And then we'll reverse our string, and then we'll iteratively reverse our string. Let's run it so we'll see how it's going to work, or what it's going to do, and then here's our A, B, C, D, E. Ah, darn it, I do that all the time. Hold on. Here's my A, B, C, D, E, and there's my recursed string. Let me run it one more time, because like I say, you can put sentences in there. The cow, the cow, I like to spell cow right, loves rain, period, hit enter, and the reversed is EHT, EHT. And the reason it did that is because we told it in our methods and the reason for that is we told it to just read a next here, so that just took my first word. I wanted the whole thing. I thought I used the next line. Whoops, hold on a second. Next line. I'll get this right yet. There we go. Next linen. Next line. There we go. Now it will let my cow love some rain and reverse it. Let's see. I knew there was a bug there. The cow loves, it's raining today. That's why I'm saying this. The cow loves rain. And there it is on my reverse sentence. So I just had the wrong command in there. I needed the next line. I was using the next. Remember, the difference is the next reads until it encounters a blank token. The next line reads until it encounters the end of line character. But anyhow, that's how it's going to work. So let's look now at our recursions. First, we're going to look at the recursive way of doing it first. I've got some debug lines in here so you can actually see what's going on here. So they're commented out right now. I wanted you to see the output first, but let's put these back in. And now when we run this method, we're going to see our intermediate results as well as the whole result. And we're going to go back to our simple string A, B, C, D. So remember, those lines that I just put back in are only for debug purposes. And now maybe you'll understand or see what's happening a little bit better. Let me bring up my console window. So this is how it starts. There's our string A, B, C, D, E. Notice what it does is it keeps stripping characters away until it gets down to the last one. It strips a character A away and then it just suspends it. That's what this one print does, where it says the new char. Let me find that debug line for you. Come on, there it is. The new char is at this position. And now that gets suspended. This kind of gets stopped in the stack because now we're going to recall our function, recursively call it, and send it a different string. Send it a different string. And this time when it rips off that first character again, the one at character 0, this time it will rip off a B because it sends the string B, C, D, E. And then the next time through, it comes through here again. Oh, and it sends the string this time C, D, E, so it rips off a C. Then it rips off a D. And then finally, it comes back and it says, oh, my length is, this is no longer true. Or this is, excuse me, this is true. My length is less than or equal to 1. I just have one thing in my string, that's the E. And that's why we print out the new S. So you can see it. And this returns the S from this previous invocation, and now it takes this the new value for SE, and what it does is starts a new sentence, because now it goes back to these suspended calls and picks up their letters. So then it found the new sentence E, the simple case, the base case. Then it went back and picked up the D. Then it went back and picked up the C, because we're going through the stack again. Then it picked up the B, and then it finally picks up the A, and then it says our reverse string. So these lines here should help you see what's going on just a little bit. How it goes down to that base case until it gets to this base case. This is the base case. That's what we're looking for all the time, the base case. And then it starts its way back through the stack. And this return returns ourselves right into this location where we print out the new temp, and then we return temp, and things keep getting added as I just illustrated. So that's how recursion goes for that base case and then drops back through the stack. So these are the debug lines. This one is a debugger, this one is a debugger, and so is this one. So you can better see what's going on. To iterate through this process, in this case it's actually easier in an iterative fashion to do this problem. All we have to do is set up a reversed string like this, start blank, and then we'll start at the end of the array for the index is equal to the string length minus 1. We'll do this while index is greater than or equal to 0, and we'll take 1 away from the index each time. We will then add to our reverse string the substring starting at index and going to index plus 1, which means just take the single character. And it will print that. And then it will, when it finishes through this loop, it will print out our entire string. We can put in a quick debug line here as well that will look just like this. Let me grab one of these up here. And we'll put this in and you'll see what I'm talking about, I hope. Except here, what are we going to do? We're going to print the new reversed string. New reversed string. And now we'll see how the iterative process works through it a little bit. Let me put in my A, B, C, D, E. And now again, the reverse string is ECDBA. We of course know that. And this is our debug from the iterative process. Notice how we build ED, EDC, EDB, EDB. And that again is similar. Compare that, if you will, to these calls and see how it's built. The difference is recursion calls itself, looks for the base case, and then backs on out. The iterative process just steps on through it. Different way of thinking sometimes. A, B, C, D, E. And there you have our two ways of doing it. This is our recursive method. These get suspended in the stack and then added as we back through the stack. These just get added one at a time through the for loop. All right, that's two of our examples. Let's look at another one. We got number 3 going here, factorial. Let's run it first. This time we're going to use an option pane. Enter a positive integer. Let's keep our numbers small because I know the answers to these ones. Remember what a factorial is? A factorial takes that number and then does a multiplication up to the number 1. So a factorial 5 is 5 times 4 times 3 times 2 times 1. So we can easily know what that answer is. I believe it's 120. So there it is. The recursive factorial of 5 is 120. And the iterative factorial of 5 is 120. Okay, and then we have down here below some debug lines that we're going to look at now to see how we went through here. These are debug lines through the recursive call. Notice how we started with the number 5 and we back out to the base case, and then we start to work our way through it. So let's see how exactly that works. This is just our main. Hopefully you remember how to use a J option pane, but if not, here's a way to do it. We put in a question. We tell it to relate this to the current class we're in, and we tell it math is fun, and our panes look like this. Let's put in 3 factorial, and we get an answer of 6. So hopefully you remember how to use those option panes from when we have seen them once or twice before. They're easy to use. You import the class. Oh, I got to make sure my imports are. There we go. You import the class, and then you use it down here to create a dialog box. There are different types depending on what you're trying to do. All right, in our factorial recursive method, it looks like this. Again, we're looking for the base case. We're looking for the number 1. We sent it the number 5, remember. So right now this has the number 5 in it. And we'll print out that number, and then we'll just hold on to this temp number so we can print it, so we can use it in our calculations and return it. We'll say if n is equal to 1, which it's not, but if it was, we'd return 1. If it's not equal to 1, then we want to do this. We want to set up this temporary item, multiply n times a call to recurse factorial, n minus 1. So we're going to send it 4. It's going to call this method again. This is going to be 4. This won't be true again. It will come down here and say temp is equal to 4 times factorial. We'll again suspend that. This will become a 3. It will go back here again, come through here again. This time temp is 3, so that won't, or n is 3. That won't work. So we'll come down here and say 3 is equal to factorial. We'll send it 2. That's still not 1, so we'll come down here again. We'll have the number 2 suspended in here. This time we'll call factorial 2 minus 1. Come back through here again, and equals 1 this time. Ta-da! It's good. So we'll return the number 1. Now remember, suspended are the numbers 2, 3, 4, and 5. So it returns the number 1 to here and does 2 times 1 is 2, and that's what we'll see here, and it will return 2 to the suspended 3. Then we'll get 3 times what returns here is 2, and you'll get 6. That will be printed here. We'll return it. The suspended number is 4. 6 times 4 is 24. We'll print that. That will be returned. The suspended number here is the 5, our first call. 5 times 24 is 120. That will be recalled, and boom, we got her. And that's how we get 120. So let's run this again and do it with the number 5. And we'll show you the results here in our console window. These are my numbers as I step through there for you. 5, 4, 3, 2. It finally came to the number 1. It returned it, and it said 1 times 2 is 2. It returned the 2. 2 times 3, the suspended one, is 6. 6 times the suspended one, 4, is 24. 24 times the suspended 5 is 120. And that's how you get it. Pretty simple. In the iterative version, again, we find it's a little bit simpler, and the reason for this is because when we use recursive calls, we usually don't use it on simple examples like this. We use it to solve more complex problems that bring in a multitude of factors that you might have to consider, that you have to be able to back out and try multiple opportunities perhaps. In these simple examples, many times the iterative way looks better, but again, we're trying to teach a new concept, so sometimes it's going to look like that. But in the factorial method, it's easy to do. We'll assume our base case is 1, and then we'll start with the number 2, and we'll iterate until our number 5, so 2 through 5, adding 1 each time. Factorial of n is 1 to start with. 1 times 2 is 2. 2 times 3 is 3 the next time through the loop, and so forth until we get to our 120. And I didn't put any debug statements in there because I figured if you wanted to see it, you could add one. But I think you're probably bright enough to understand what's happening there. So here's the code for this one. This one's a little harder to get all on the screen because it goes so wide. But you know what? I can do this, I suppose. Although sometimes these things get picky about how you line them up. Math is fun. Enter a positive integer. Let me just get rid of the word positive there. And we'll just add the plus sign. Enter a plus integer. So we can see all of that line on there. I want you to be able to see it. And then notice it's continued down here. So now, let me show you this. Here's our main method. Take a quick snapshot of that. Enter. The rest is just my heading. Got to get that though. There's my main method. 1, 2, 3, 4, 5. Here's my recursive and my iterative method, and end of program. All right, we got one more example and this will be done for today. Anyhow, we will have some probably other of these examples. All right, this one is going to print some numbers vertically. So let me show you how this one's going to work. It will ask us, oh no, it won't ask us for a number. That's right. We're going to hard code the numbers we want to work with. And what we're going to do is we're going to give it the number 1, 2, 3, 4 or any similar number. And what it's going to do is, again, work down to the base case and try to print this number in a vertical fashion. And we have both ways of doing that as well here today. So there's our main method. Nothing fancy there. Again, just our 2 calls. That's what most of our main methods have been, except for our last one where we had that user interaction. Okay. Let's look at the recursive method first. Remember, we're looking for the base case and we want to tear this number apart and turn it into a vertical list of numbers. So to do it recursively, we'd have something that looks like this. Again, you're looking for the base case. If n is less than 10, well, when we called this the first time, we sent it 1,234. So n is not less than 10. You know what? Let's run we'll go through this again, and then I'll run a different example for you. So n is not less than 10, so we will not come down and do this line. We'll do this instead. We'll say our new value that we're going to work with is going to be n divided by 10. Again, this is a debug statement. And then we'll recursively call ourselves with our new number. So what this does is n divided by 10, what it will do is turn our number from 1, 2, 3, 4 into, as we saw in our output, 1, 2, 3. Because we're trying to get to that base case. So we called this function again, this method again, with this new value. Remember, this function call suspends process of the first call, and so this line hasn't been executed yet. So now we send it 1, 2, 3. We again find that n is greater than 10. We'll come down here, divide 1, 2, 3 by 10. That means that the number we're sending it this next time is 12. We'll come back here again. So again, this is suspended. We'll come back here again with our 12. 12 is still greater than 10. We'll come back here again. 12 divided by 10, we'll send it the number 1. Call it with the number 1. If n is less than 10, this is the base case. Base case. And we'll print it out. And now we'll start to go back through our list. And what we'll do here is we go back through our list. Remember we had these suspended numbers? And what it will do is it will go back, and then it will, after it finds the base case, it will find that your suspended numbers and rip them out and put them on your list. And that's done with these calls here, with an n divided by 10. This is a debug line, and no other one is, I don't think. No, just that one. Because this is the line then as you return those values, n modello 10, remember that's just going to give you the remainder. So that's what happens here on that n modello 10. We get into this, let me get to the output. We get to this n modello 10, that makes this into a 2, and it gets printed. And then it goes back, n modello 10, that the remainder here is 3, and it goes there. And then n modello 10, the remainder here is a 4, and that goes there. And then finally, our iterative process looks like this. It's actually a little bit more complicated this time, because our problem maybe was a little more complicated. But again, we're kind of assuming our base case here is the first one. Our left n piece is going to be equal to n. And while our left n piece is greater than 9, well, again, we're looking for that single digit, we'll have our left n piece divided by 10, and we'll keep track of our number of tens each time through here. Number of tens is a power of tens that has the same number. So 2, 3, 4, 5, then n's tens is 1,000. 3, 4, 5, n's tens would be 100. Like that. And then we'll come down here and print this out simply each time through here. Once we're down to we've got those ready to go, we'll come down here to our number of tens. We'll iterate that while we're less than 0, and we will again notice our division here. Index is equal to index divided by 10. That's how you're going to do that for loop, and that will give you an integer number, remember. And we'll print out our n, and then our n at the end of our loop applies the Modello operator and goes back through again and works in the same fashion as our recursive call, just with a little bit different style. So that's your introduction to recursion. We've got some other examples that we might get to this week. Make sure you're looking through the book in that chapter. Your lab this week, you're going to really be translating pseudocode into a recursive solution. So hopefully you'll not have much trouble with that, and you'll get started on it quickly and enjoy it. You have to make sure you use a recursive solution in this week's lab, not an iterative solution. So that's it from me. This is Owen Riley saying we'll recurse with you later. Have a good one.